Assalamualaikum and good morning. My name is IRFAN Daniel bin HAAZIZKIN, and for today I'm going to do a brief and short presentation about Lab 4 report, that is disc brake for the subject vehicle braking system. Okay, next I will go into the outcome and data for this lab session. Okay, these are the parts and components of the disc brake. That is one. Now, the number one that shows in the image is the guide pin, and the number two, that is lock pin. Three is the pin boots, and four is the mounting bracket. Five is the dust boot, and six is the boot swing, and seven is piston boots. Eight is the piston, and nine is the piston seal, and 10 is the cylinder body. 11 friction material. The 12 is the brake pad. The 13 is the shim, and lastly the 14 is the pad clip. Alright, for this next slide I'm going to state out the results of the condition of the disc brakes, including the condition of parts and the inspection of conditions. For the condition of parts, as the table below stated, the wear indicator of the disc brake system is in good condition. Meanwhile, the disc brake surface have a smooth surface, but it's not in good condition and rusty. For the outboard brake shoe pad, the condition is it still can be used and good, and the thickness is still okay, that is 6.47 millimeter. And for the inboard brake shoe pad, is this the condition is still good too, and the thickness is 6.98 millimeter. For the piston of the disc brake, it doesn't get stuck and working well, and means it's in a good condition with no rust. And for the cylinder bore, the cylinder bore have a smooth surface and doesn't contain any scratches, means it is in good condition and doesn't contain rust inside. Next, for the inspection of condition, the run out measurement for this lab session is the surface is fine and in good condition to wear. And for this thickness measurement, there are six measurement that we that our group have have measured. That is first 10 mm, second 10.02 mm, the third is 9.98 mm, the fourth is 9.96 millimeters, the fifth is 9.94 millimeters, and the sixth we get the same as the first, that is 10 millimeters. Next, for the rub test, all the surface of the disc is in contact, but it but from the rub test, the surface is a bit rough, but that's a normal condition for this brake system. Next, for the guide pin and lock pin straightness, the guide pin is straight and in good condition. Meanwhile, the lock pin is jammed and it cannot be released from its position. Alright, for the next slide, I'm going to go into details of our group discussion and questions and answers. Based on the finding, what is the condition of the brake pad and should it be replaced? And the answer that our group have considered is, based on the finding of this lab session, we discover that the brake pad is still in good condition and that the brake pad can continue to be wear and use because the minimum wear condition for a brake pad to be replaced is at 3.2 millimeters thickness, but the pad thickness for this lab session is 6.47 millimeters outboard and 6.98 millimeter inboards. That makes the pad still can be used. Then two causes of rotor thickness variation is brake pad wear and heat distribution issues. So this is the correct repair procedure for thickness variation. First, inspect and identify the root problem of uneven brake pad wear or heat distribution issues in the entire braking system. Next, change the brake pads to a new one if uneven brake pad wear is the issue. Then, check the calipers to ensure it is functioning properly. Resurface or replace the rotors depending on the extent of the thickness variation, and bleed the braking system to remove any air that may have entered the brake lines. Then, for question 3, what do we understand about run-out measurement data? So, as part of the brake replacement procedure, it is essential to check the disc brake run-out. Measuring the run-out is an essential procedure to guarantee the safety of the driver and other road users. It can reveal whether the discs are malfunctioning or have been installed improperly. Any reading over 0.07 millimeters can have negative impacts on the brake system as a whole and cause vibrations in the brake pedal and steering wheel, which could endanger the safety of the driver and any passengers. And for the fourth question, what is the finding for the guide pin or lock pin straightness check, and what can happen to the disc brake system if the guide pin or lock pin is not straight? Based on the answer of our group in this finding and observation for the guide or pin lock straightness check, one of the lock pin is jammed and cannot be removed from the caliper, and the other one is in good condition and can be removed. For the answer of the question, if the guide pin or lock pin is not straight or have some issues, the brake pad won't meet the rotor properly every time, which can cause damage to all parts involved and not be able to functioning with full braking performance. Last but not least, for the conclusion from this lab session, our group has concluded that the disc brake that we use in this lab session is not safe to use on any vehicles, especially cars. After that, we also studied the benefits and drawbacks of disc brakes during this lab session. Then, during this lab session, we have assembled and disassembled the brake disc system, which allow us to learn about all of the parts and components from minor to major in the brake system. Finally, our research has taught us what run-out measurement is and how to determine whether the rotor measurement result is good or bad for the vehicle braking system to be used on the road. That's all from me for my brief and short presentation today about lab report 4, that is this brake system. Thank you.